All right, guys, here we are. We are in Module 5, S-Domain Circuits and Systems. We're going to wrap up this course with learning about the S-Domain and Laplace transforms. I'm just going to go ahead and give the brief module overview here, or module introduction, I should say. What we're going to talk about is going to start with a review of first-order circuits. So you remember RL and RC circuits from EE220, where we have something like this or something like this. These are first order circuits, right? RC, RL circuits. These are going to be the type of circuits that we're back to looking at in this particular module. We're not looking at sinusoidal behavior anymore. We're more interested in solving the circuit and in the Laplace domain here. We're going to talk about what all that means, but I just wanted to basically take the time to review some of this stuff that we did in 220, which is solving these RC and RL circuits in the time domain, looking at the transient response to some kind of an impulse, or if we had a voltage source out here with a switch open, and then at some time we close that switch and the capacitor voltage ramps up. We solved all this stuff in 220 using differential equations, and we kind of derived what we called the Fife equation here for RC circuits and RL circuits. That's derived straight from solving the differential equation. But in this module, we're basically going to be looking at how to model these circuits in a different way so that we can solve them without using differential equations. It's not necessarily easier. I think some people think that it's a good alternative to solving circuits using differential equations, but I want to make it clear that it's just another way to solve circuits, which has kind of been the theme of both of these classes, is how can we basically equip you with as many tools as we can so that you can solve circuits in whatever way you see fit. So we're going to be doing that in this module. We're going to start with that review. So after this first module introduction video, you should proceed to the review of first order circuits if you wish. Obviously, that's not necessary if you feel really confident with this stuff, but I think it's probably a good idea to just check out the review videos. I only put a few of them in there, so maybe just watch that review before you get into the rest of this module, okay? So we've got the unit impulse, the step functions that we're going to talk about. Those are important in Laplace domain circuits for modeling our input signal in particular. Then we have the Laplace transform itself, which is a mathematical operation that we are going to learn how to use and how to perform. And then the inverse Laplace transform, we're going to talk about all that stuff in one section of this module. Then we're going to talk about properties of the Laplace transform and different Laplace transform pairs. Then we're going to talk about how we can analyze circuits with the Laplace transform. So basically, we need to introduce the Laplace transform mathematically before we can talk about how to apply it to circuits, okay? And then here we'll also talk about Laplace transform pairs and the partial fraction expansion method, which sounds more difficult than it is. And finally, we will get into modeling or circuit element models in the S-domain for resistors, capacitors, and inductors. Okay, so I'm going to go ahead and end this introduction video. And in the next video, hopefully you proceed up to the review, which is at the beginning of this page on Canvas, and get started with the review. And once you finish the review, then we'll move down into unit impulse and step functions.